very senior and experienced product manager from Datalogic. And before I get started, I would like to just introduce very briefly myself and Data Sensor. Data Sensor started in 1984, so it's almost 37 years old, and established as one of the very first sensor companies in India. And at that time, it was a subsidiary of Datalogic, which is now a very large leader in industrial automation products. And started as a subsidiary, and especially with some of the photoelectric sensors used for packaging and many other industries. 30 plus years later, we have diversified into many different products: machine vision, safety, of course, sensors being one of our core products that we are still offering as a distributor, a partner of Datalogic, and many more. And I'm the managing director, and have been with Data Sensor since its recent inception. And I'm very pleased to welcome our panelist, and primarily Mr. Alberto Fabbri from Datalogic, who comes with a very vast experience in the sensor market. And Alberto started many years ago when Datalogic was Data Sensor. So it's Datalogic or Data Sensor is actually a sensor company. That's how it started, and has been in various roles. Firstly with R&D in a deep technical role, working in the sensor and RFID range of products. And he was taking care of developing the new sensor business as well in the US. So when he moved to the United States, he started a new sensor business unit there, spent many years, and not just worked on developing new products, but also scouting new technologies that can be used and incorporated into Datalogic's products. And 10 years ago, he also had an advanced degree in the Masters of Technology in the University of Bologna as well. And about 7 years ago, 2014, he is now been a senior product manager for the sensor business, looking after the entire product range of Datalogic sensors and safety. And of course, he's being Italian, he's very passionate about sports, football, I'm sure, as well as food. And I would like to take this opportunity to give a very warm welcome to Alberto, who's going to be talking about sensors in various industries. Hopefully we have a lot to learn. The format of this is going to be about 40 minutes, 45 minutes of a presentation that Alberto will be going through with us. Now, as an attendee, please raise your hands if you have any questions, type it out in your chat box. We'd love to be an interactive session. This is your learning. This is the opportunity for you to ask any questions about sensors, automation, etc. has been on the rise. Take this opportunity, please ask your questions, and we will answer all of them. If we can't get through it within this time, we will make sure we answer this in an email later. And for everyone's information, this session is being recorded, and a recording of this will also be shared with you in case some of you could not make it through the entire webinar, or some of your colleagues, for instance, could not make it. So, that having said, Mr. Alberto, the floor is yours. Very warm welcome and happy to have you with us.
So, thank you very much, Gawa, and good evening to everybody. It's a pleasure to be here to explain to you some details, some hints, and some more things about sensor in general. Today we are speaking about the role of sensor in the industries, but we are speaking also about products. So I think it will be the best solution to speak about this kind of role of these products in the industry, having directly experience with product and to understand what are the applications of these products. So Let me share the monitor for the presentation. I hope you can see it.
Yes, yes, we can, Alberto.
Okay, very good. So we can start first from let's say to speak about what Datalogic is doing, has been doing during these last years about developments in the field of sensors. We have made a lot of investments as a company in order to discover and apply new technologies for smart sensors. So smart sensor would be for sure the future in the industry development, because industry today needs more information from sensor products, not just on off in order to understand if objects or target or kind of product is going through the production flow, but I'm sure that industries will start to ask also about some parameters that are coming from the sensor, and then also they will start to ask for some details about parameterization for maintenance and also setting for different formats. So the best one of our best development during these last years was exactly to develop a smart sensor in this direction. So we started to develop a new ASIC, which is a component inside the sensor that can enable sensor to be smart, so to communicate with the customer. And it can be also adapted to any kind of condition detection that can be found in the field. Then this ASIC is not only a kind of communication product, communication components for the system, but it is also the core of the photoelectric sensors in our portfolio. So we have started to engineer our portfolio with this new technology in order to get more and more smarter sensor as a solution for the customers. So this was of course, one of the most important investment that we made, but we also made another important investment, which is related to a new breakthrough product on the market, which is called Smart VS. And the placement of this product is exactly in the middle between an application sensor, which is a sensor that can solve vertical applications like mark reading or other kind of color reading or let's say glare reading, all this kind of very specialized detection activity, and a smart camera. Practically, the Smart VS will cover this kind of a very big gray area between those two typology of sensor, and it will use the technology of the vision, but with a very simple way and a very simple method to use the sensor, which is very near to a photoelectric sensor.
Alberto, just a quick check. There is some static coming from your mic. Are you using a headphone by any chance, or you're using the...
No, I'm using the computer.
Okay. So I think there is a little bit of...
Maybe I can use the headset. Maybe it's better.
Maybe that might improve. So there's a little bit of the static.
Sorry for that. Can you hear me now?
We can, but there is still that static. Do you have to change the mic settings in your audio, maybe?
Maybe. I don't know. That's... okay.
I think it's much better now.
Oh, it's much better.
Yeah,
Perfect.
yeah.
Okay.
Yes,
Okay.
thank you.
Sorry. Thank you. As I told you, this product is exactly in the middle of this big area between the application sensor and smart camera. Of course, one of the biggest advantages that you have with this kind of product, like Smart VS, is that instead having a smart camera, you can have a web server graphic user interface, a lot of different capability to set up the sensor with different receipt for the production, but in a very simple way with a push button on the sensor, exactly as it is for a smart sensor or any kind of other photoelectric sensor. Of course, this means that you won't have the need to understand about vision. You don't need to struggle with spatial algorithm, and you can really solve, of course, very simple application, but simple application that with a smart camera, they should have a very big cost, which is not, of course, the right solution, and without the need of expertise people, which is still not the right solution for very simple applications. Then, speaking about the other side, for the application sensor, we can really put in place of application sensor our Smart VS, especially when we have to fulfill any kind of peculiar application where the customer needs to change format very easily without having mechanical parts or other kind of complex system with sensor. And we can save money in terms of bill of material for the machinery itself. So one of the most important principles is that we can save cost for the TCO, and we can really have a very simple device in order to solve any kind of sensor application. What is the main concept which is behind this product? The Smart VS actually is a binary selector, so it's a binary classificator. You have to train the product with good and not good condition, and then it can run in order to solve all the application with check label presence. So, I mean, if you have to check the presence of a label on bottles or any kind of other kind of packaging, same things if you have to check the side, the orientation side of a product. If you have to check, for instance, the presence of a cap on vials, on bottles, and so on. And then also if you have to check the presence of printing text, which is supposed to be on a can, on a label, and so on. If you have, I don't know, I've seen that someone raised some questions. Maybe we can try to answer them a little bit later. I don't know. That's if you have some kind of important topics, please let me know. We can also stop for a while and try to answer you. But I would continue in order to give you more details about this product, since the product is made by a very nice illuminator, white LED illuminator with polarized light. Then we have a pointer. Dimensions of the product are very compact, like the same dimension of the Matrix 220. We have the capability to have a kind of rotatable connector on board, so you can really set up the sensor as much as possible in the best condition for your mechanical requirements. The field of view comes from 22 to 55 millimeters at let's say from 22 up to 16 millimeters, and from 55 to 41. This depends on the distance that you have to read the target, that comes from 50 to 150. And then, of course, everything is enclosed in a kind of very rugged metal housing for any kind of industrial application. You can see we have an illuminator pointer in order to give the capability to set up the sensor on the application, pointing the region that you want to detect in your target. Then we have a big teach button to train the sensor. And also we have the capability to connect the product with power and IOs, and also with the Giga Ethernet connectivity. Then inside the product, we have embedded some kind of advanced algorithm for the artificial intelligence, and this kind of machine learning customized algorithm in order to make this kind of application, which is related to binary classification. And then we have also a system on chip with multi-core processing in order to be fast in any kind of image execution. Then we have what is another thing that is very, very useful is that we have also a kind of capability to illuminate the target with a red or green light when we can detect objects which are good or not good part in front of the sensor. And this will give even more information, visual information to the customer in order to ease any kind of installation in your machinery. Let's say that the important, the important thing is that today we have also a very good user interface in order to give the customer the status of the sensor in any kind of condition during the running or during the setting phase. This is the connectivity with the customer systems, with power supply connector and IOs and the Ethernet connectivity. And once again, we can start to speak about applications. So, as I told you, this is a binary classificator. So it's especially used in case you need to check the presence or the orientation of objects. And you have to train the product in a very simple way with good and not good condition. How is made this training? The training is very simple. You have to place in front of the sensor the good condition. Then you have to keep the button pressed for some seconds. Then you can acquire with a short pushing of the button the good condition. You can also acquire multiple good condition, not just one, in order to set a more precise detection. And then you can pass to the second stage, which is the pushing the button again with in order to check and acquire the not good condition, which the acquiring of the not good condition is made in the same way of the good condition. And then pressing again, you can start and run the product. At this point, the sensor is ready, and every time that an object is passing in front of the sensor, it can classify the object good or not good, without making any kind of programming with vision tools, with other kind of stuff, just using the push button that you have on board. Then you can make the same activity that you have already seen with the push button on board with the user interface on the product. The user interface is a web server, a smart graphic user interface, which is inside the product. So you don't need to download any kind of application from internet and install it on the PC. The user interface is already inside the product. You just connect the product with a PC and the cable and Ethernet cable. and then typing the TCP address on the Google bar, you can really connect with the product and make the same activity just pressing with clicks on the buttons of the user interface. And you can see in the user interface what you're really acquiring. You can see also the big image and the small images in the data set for good and not good condition. And then at the same way, you can go and start with the system. So once again, very simple, very direct, and no problem to set the sensor in any condition where you have to detect the presence or orientation of objects. Then what happens about the outputs? The outputs of the sensor, they are three output. We have three output on board. These three output practically gives to the customer the information that the sensor is going on, and it has detected a good or not good part. So we have one output for the good, one output for not good, and one output that is the gate, the data valid gate, in order to give the customer the information that the product has detected the part in the time which was requested, and the customer can read the output, which is good or not good. Another important thing about the product is that the product will respond in 50 milliseconds of time, and it will be kind of deterministic time. So we don't have any kind of difference in terms of responding time when light is changing or background is changing, or the product itself one time has the cap, the other time has not the cap. It will be always 50 milliseconds in any conditions. And the maximum images that we can load in the sensor for the detection is 6. You can load up to 6 images. Doesn't matter if you load 1 good and 5 no good, 2 good or 4 no good, or vice versa. It's important that the sum of the total images will be always 6, responding always in 50 milliseconds. Then this is an example of the setting. You know, if you have to detect this kind of feature in order to see that the side of the, to detect the side of the part that is going to be analyzed, you have to put in the middle of the two squared red pointer light the feature, and then the product will give you the information that you are detecting a good or not good part, exactly illuminating the product with a green or a red light. And this will be also very useful for the customer, so it can really see at the glance what is going on in the system. Then we can speak about a little bit about the setup, the scenario setup of the sensor, because the sensor can support different setup. The basic setup is to give the sensor an input trigger, which can be done with a sensor or with a push button or with an electrical machine phase by a PLC. Or we can also have a scenario with, of course, always the trigger and then a control panel communicating with the product. Or in case you need an extended scenario, you can also, since today in the many applications, it's needed to have a PLC, a monitor, the product itself. You can also extend your system and having a system with more possibility to make maintenance, to make also a kind of graphic user interface or HMI and so on. Then one thing that important is that to placing the trigger input with a photo sensor or whatever, it's important to have a good precision in terms of detecting the correct part of the object. But I can tell you that the product is very tolerant between and in terms of millimeters. So you don't need to make any kind of setting. This is another thing that will get easier, of course, the product. So you don't need any kind of very precise detection of the target. It can be very tolerant, and it will be also easy to place any kind of trigger in your system. It's important that when you trigger the sensor, you have to actually to get the correct part that you want to see of the object in order to give the sensor the correct information about good or not good part. Then this is a kind of a very simple application about the cap presence on wires. You can see what is the user interface during the sensor running. So you can see a clear image on the monitor, and also what was selected about good or not good part. Same for when you detect a good part, and then of course you will launch the learning of the sensor, and then it will be ready to run. As you can see, we have a very complete user interface for the things that has to do with the sensor. You have some kind of area which is intended for the statistics. Then we have the area where you can see what was good or not good. And then we have an area here which we call stripe, image stripe. And this is very interesting, in a very interesting point. If you want to improve the detection, you don't need to go in the graphic tool or software tools. When you see an image that it was intended to be good or not good, but the sensor didn't select it in the correct condition, you just take an image from the stripe, and with drag and drop procedure, you can put it in a good or not good part as you prefer. So this means that the sensor will learn the condition, and then it will be ready to start again and avoid the fail on the condition that you wanted to detect. Then another thing that is pretty useful in the system is that you can set the sensor for I/O, and also you can define some parameterization for the trigger input. This is very useful when you have to set up the sensor, because of course you can use these parameters instead of acting on the sensor, just moving some kind of parameterization for the time, polarization of the trigger input, and so on. So this is, we call it environmental sensing. And then we have very simple and easy accessories, because the product is very easy to use, but also very easy to install. You just need a power cable, an Ethernet cable, if you wish to communicate with the sensor and the computer. And then we have also some adapter to make your life easier when you have to connect with Ethernet in different modes. And then this is always supplied with the sensor. We have also a very flexible bracket in order to install the sensor in the right position on your machinery. Then, going to the application. Today, the market, which is demanding a smart sensor, is increasing pretty much, because sensors are not, as I told you, are not anymore kind of on-off detection object with very simple optical functions. Today, you have to detect a very difficult targets sometimes with transparents, with filled by liquids, or with very strange labels, very colored one. So it will become very, very difficult with an optical sensor to adapt your detection in all these kind of applications. Today, with a kind of product like Smart VS, you can cover all this kind of application, especially in filling machinery, when you have to fill bottles with jars, flasks, and so on. This is especially for beverage applications, especially where you have to detect if a label is present, if you have to detect that the cap is present, or that your bottle was filled up and the liquid is still present. One thing that is very important is that we have tested this product in several bottling applications, and we were very successful, especially with transparency and glass reflections type bottle. That was very good because usually you get a lot of trouble with these applications with former sensors like photoelectric and so on, especially if you have to adapt your production to different formats for bottles and so on. But we were very winning in this application because we could adapt very easily, even with very special materials. So this is very important. This product can work really well in any kind of course, light ambient condition, but also with very different materials on your machinery. Then, which was the success factor? Distance was correct, so 50 by 150 is a good distance for this kind of applications. Of course, the customers will like it very much the pointer, polarizing illuminator, and also the very easy setting by the push button. In some cases, actually, we had customer for the bottling application that they didn't want to have any kind of graphic user interface. They just wanted to set up the sensor with the push button because they wanted to have the most possible easy situation, even if they had to make some kind of let's say some kind of recovery activity abroad with different languages of operators and so on. So they didn't want to get in trouble with the graphic user interface, and they liked very much the setting by the push button that was very easy also when they wanted to change the format. You can change the format actually through the Ethernet communication because you can make it with GUI or even with a kind of very simple string set by a PLC. But in case you don't want to get any kind of connectivity with Ethernet or other stuff, you can easily use the push button on board because even when you change the format, the time that you have to stop the machinery and acquire the new condition is very short. Of course, another thing that was that we are pretty color independent, so we don't mind about different surfaces or colors of the material that you have to detect. And another thing that was very important for them, especially in the bottling application, is that the product is deterministic and it will respond always in 50 milliseconds. Another application where we were pretty successful was the cosmetic applications, because in cosmetic market, you know, you have a lot of different type of packaging. So you can go from matte and up to glare, up to color and very colored materials. It was not easy sometimes also to detect labels if you had kind of packaging with glass and fill it with maybe kind of different cream and so on with different color or glitters inside. And sometimes with the systems of sensor that has to detect a cap which is present on the jar or something like that was not very easy. With our product, you just install the product in the machinery at the right distance, and then you make your acquisition of the good and not good, and it's ready to start without having any trouble when this kind of very special format will flow through the machinery. So it was very, very interesting to see people excited about the simple situation and also the simple commissioning of the sensor without having trouble like with standard photoelectric or with the kind of let's say programming of the sensor for vision tools. Also in this case, we had application running with in order to detect a label, cap, and also in this case, some kind of orientation. Actually, check printing was also one thing that was asked in the beginning. Today is also been asked not only for the cosmetic industries, but also in the pharma one and in food. We have a very nice application running in Loacker, which is this kind of biscuit producer that is checking if the expiring date is present, is printed on the packaging or not. We cannot, of course, check the quality as as a smart camera can do, or what is written, OCR or CV. No, we cannot do this kind of checking, but we can check easily if the text is present or not on this label.
So we have some questions. Maybe
yes, please.
We could collect some of these, have a small break. So yeah, people, there's some questions that are coming in from the chat window. If there are some other questions that you have, please, feel free to type it out, or if you want, you can also unmute yourself and you can ask your question. So I'll just take a few which is coming from. So Devanshu is asking sensor we can use in MIG welding. So is this a sensor that can be used in welding? Have you seen any applications in welding, Alberto?
No, not in
probably.
welding. I mean, depends on which kind of welding. If we are speaking about welding, which is made by electrical arc, this kind of welding, which are emitting ultraviolet and very strong electrical discharge, this was not used in this kind of application. But this kind of application for the packaging, where you have to weld with hot, let's say, hot principle, so you have to get part welded by high temperature on the plastic and so on. We made some application like this in food industries, but we also made something like that in this kind of other industries where they had to weld two plastic parts in order to make bracelets and so on. So this was a very, very good application. We had to detect which was the ending of the writing on the bracelet, and then the machinery was cutting the bracelet and welded. So this was another application where we have been successful. Another kind of application for the sealing industries that is very interesting is that we can detect very transparent sealing adhesive tapes which are going on maybe very this kind of white boxes which can be very shiny, so where you have a lot of reflection. In this kind of application, we can be very successful. Sometimes I saw people struggling with camera, I saw people struggling with photoelectric sensor, but we could go very easily even through these applications.
Sure, thank you. And so the next question that is coming in is, now if a good product is segregated as good and no good, or if there are multiple no good cases and only one good case, then is there a configuration possible for the sensor?
Of course,
Yeah.
Yes, you can easily acquire one condition which is good, and since we have the capability to store 6 images, you can put 5 no good conditions, no problem.
Yeah. So you can have multiple.
It's important
no good
that
conditions.
the total numbers of images that you are going to acquire, it's always a 6, because up to date we have seen that 6, it's a very good number in order to cover the majority of the application. that we have faced up today, but it's also a pretty good number for the algorithm itself. In any case, since we have seen that increasing the number of images could be fruitful for applications where you have a pretty good variety of the target and pretty good variety of good or not good part, we are also investigating a way in order to try to increase images, of course, increasing also the response time, but to cover some kind of application where maybe more images are required. But this is something that is under study, as also the anomaly detection. I don't want to hide that we are also going to now to make a lot of benchmark on neural networks in order to find which could be the right algorithm with neural networks to make the anomaly detection in an embedded device. This is very challenging, I can tell you, but really very challenging, but it's something that is going on in this period. So we are making technology scouting, and we hope by the half of the next year to have selected the good technology for our applications. Up to today, we have this possibility, and I would say that it's behaving pretty well.
Thank you. So related to that, Satish Kumar is asking if we have 6 images, and so if we are trying to identify the product variant, and so if you can save only 6 images, then what if we want to monitor more? So if we have, let's say, a 7th, then we need to remove one of the images, so it can only do that. Is that that's probably how it has to be done.
Today, this kind of number is fixed to 6, so you cannot add more images. You have to delete one of the others. This is true. This is true. This is also a reason why we are trying to see the possibility to increase them for some cases, of course, but today is fixed to 6.
Yeah. Hitesh is asking, and I think you answered this before, can the sensor read the alphanumeric characters punched on the metal flanges? So I think Alberto mentioned that this does not do OCR, OCV. It is mostly, it is classification. It is identifying and binary classification.
Yeah, you're right.
Alberto?
We cannot make OCR, OCV. It is not intended to do this kind of job, of course. But we can really easily try to see if the printing, let's say, that can be made in different way. But in any case, if the text or the image, the texture that you wanted to impress on your object was made or not, I can tell you that. We are very successful with shiny surfaces. So if you want to use a glass, kind of, even some kind of metal, which can be shiny, so something like that, we don't have trouble to detect things, even in this kind of difficult conditions.
Very well. I think last question is from Vinod, and we can continue. We have another 13 minutes left. So the dealer network in India. So Vinod, Data Sensor is Datalogic's partner in India, and you can reach out to us. If Akshay or Adi can, I think there's the contact information will be shared. You will get an email if you've registered for this webinar. And you can always reply back to that email or contact us through our website, datasensor.in. You can email us, and we'll be happy to assist you with these products. So we'll share the contact information.
Of course.
Great.
Of course.
Thank you, Alberto. Please continue. Yeah.
Okay. So going through the applications, also this kind of, in order to understand also other kind of application, also this kind of, very, very shiny targets like this kind of holographic figures, they can be easily detected without having any kind of problem with optical situation. And also, if you have a very dark color on dark color, it's pretty easy for the data VS, for the, let's say, for the smart VS to find out if the ceiling is present or not. So this is very capable also in case of very difficult surfaces that could be difficult for camera, for normal camera, or also with optical sensor. Now some kind of success cases is going on. So we have made also some tests on before. These were tests that when we started to commercialize the product, we went to the customer, that we worked with them in the application, presenting the product and working with the machinery, with the product, with the customer. In this case, we had to detect the writing, the text, our back test on kind of region of the object, and it was to detect for the presence of the writing, good or not good part. Of course, acquiring the text and acquiring the part without test, we could go easily through this production. And of course, when we didn't see that there was the airbag writing on this area, that was discarded. The part was discarded and put it in the loop again in order to be written in the correct way. Then this is an example of multiple images, no good, and one good image that we just told before. In this case, we are in a blow injection application, plastic injection application for milk bottle. And we had to detect the presence of this part of which is a kind of discard part in the bottle. So we had to detect the presence of this because if it was present, we had to cut it. And in this case, we just acquired the good condition, 5 no good condition because the object can be presented in different positions. And then we could go through the system very easily without making any kind of difficult programming or any kind of multiple sensor installation to check the presence of this object. And it was very easy to set up the sensor and make it running in the production. So this is the example with multiple images which are not good and one image that is the good part. And remember, this is a binary selector. It's not something that is like vision 2 camera, something like that. This is a binary selector. Then in this case, we had to see if this part, always in automotive industry, was matte or shiny. You didn't need to find any kind of problem about geometry or presence of something on this part, just if the surface was matte or shiny. With some sensor, we got some trouble in stability. With the Smart VS, we could go through very easily because we are not affected about the problem that a shiny surface can give in a kind of surface detection application. Then pharma industry. We had to detect the side of this small vial that was a container, was containing blood, human blood, to be examined during the machinery flow. In the beginning, we needed to load the machinery with vials, and we needed to understand which was the right position of the vial. Then, if the position was not good, the machinery was just going and change the, let's say, the side of insertion of the vial in the machinery. You can see here we installed 2 of them because the machinery needed to go through with a double channel in order to improve the number of parts processed in the machinery. So we installed 2 of them, and we could go easily because because of our GUI, graphic user interface, which is a web server embedded in the sensor. We could go very easily and make the installing of the Smart VS on this machinery. This is an application where you have to detect the correct side of a part. In this case was just a vial. In some cases could be a kind of bottle or any kind of other containers with liquid and so on. One thing that is important, once you get the condition, the acquisition of the image, and you have also liquid part inside, you are not affected about this liquid part inside. So you are even very stable with filled parts. And this is very important in this kind of applications. So one thing that is important and I would like to highlight to you is that we have today available a very nice demo case that you can use to make demo to your customer, to any people which is interested about how to work the sensor. And the one thing that is very good is that it's a very compact case, and inside we have a very useful tool also to make the installation, correct installation on the machinery. You see here we have a kind of magnetic base. So this is the magnetic on off. And then you can use this kind of standing device to install your sensor in the system of the customer, even of the customer. So you just put all this part together, and then you can get the sensor working in the machinery. Together, you can find also the power supply unit and also a small cable with the trigger. So if you need to make a demo on the table, and you need, of course, the trigger to make the snapshots of the product, you can use this small cable to power supply the sensor, and you can use the push button in order to give the trigger to the sensor and make it running. It will be very easy to make a demo with the customer, because one thing that is very important with the Smart VS is that the product must be, I mean, in order to make the customer understand how much is useful this product and how much is easy to set up, is to make a demo with the customer and with the target of the customer. So the customer can see that with its own target that it has to use in the machinery, it works very well with the sensor. And we made this in any kind of application for, let's say, bottling, pharma, and also food and beverage. So I would suggest that the price is pretty low. It's not a matter of price. You can also go very straightforward on the machinery, and you can install the product there and use it directly on the customer machinery. And this is a very great value in order to present and promote the product. Then we can go ahead speaking about what we have done about the improving this product since we have announced it to the market 1.5 years ago. We have made some kind of firmware upgrade in order to make and easy some kind of communication features with the customer. Then we have available today function blocks for PLC that comes from Siemens and Rockwell. So you can download those kind of function block from our site and use them directly in the PLC in order to make today just the received selection, but it will be very easy to make it because it's already done in this function block. Then one thing that is going on December, we have also developed a protocol which works with TCP/IP on the Ethernet, of course. And with this kind of interesting protocol, you can make a lot of things that you can make also with the graphic user interface, just communicating with the sensor. So you can set up the sensor, you can set some parameters, you can read some parameters, and you can go just, it was the user interface. This, and also you can also download, upload a receipt, and so on. This I think is very useful topic, and it will be available on December this year. Then we have also a kind of development roadmap for this product, because we believe pretty much in this product. And the next things that are coming, it will be by the Q1 of the next year, products that can handle much more images than 6, but really much more. And also, of course, it will have, since the images number will increase, also the time of elaboration will increase, but it will be always the same time. So once the time has been decided by the system, it will be deterministic, okay? It's important for us, this kind of deterministic approach, because since we have also to go in the sensor area is very strictly related to deterministic response time. So, of course, it's a matter if this time is enough for your application, but once the time is enough, you know that the product will respond in that time. And let's say the through output of the machinery doesn't change because something has been changed in your product during the elaboration of the same product bunch. So this must be very clear. Then we are speaking about something which is also very, very important for the future in the industry, because we spoke about smart sensor, we spoke about application related to smart sensor, but how the smart sensor will evolve in this kind of world in the next future. Of course, one thing that is very important is that the evolution will be led by the communication. So today the sensor can communicate 1, 0. Just today, can also send and receive parameterization. And in the future, this will be more and more present at any kind of system level in the sensor. Of course, the system that has been chosen for the smart sensor in general is the IO-Link communication, because you can have a lot of advantages in the future with this kind of communication. You can reduce cost in the system because you can have always very standard communication in terms of cables, in terms of interface on the sensor, and also in terms of interface with the system. You can also have the great advantages to have diagnosis on board of the sensor, and also configuration and monitoring of simple physical measurements. Then what is the IO-Link? IO-Link, it's a serial communication that can also be shared with a digital I/O. Today, it's COM2 and COM3, which is the 2 different speeds. There was also the COM1, but COM1 today is too slow. We have as a standard COM2, and in some cases, especially for measurements purposes, we have the COM3. Then what is that is clear, Datalogic has chosen the double channel. Double channel is the most useful communication with IO-Link, in my opinion, because you can have serial communication and digital I/O on one pin. But one thing that is very important for any kind of application is that on the other pin, you can have the digital output as a nominal frequency, switching frequency of the sensor. This means that you have the possibility to go very fast in very fast system because you have the digital output at nominal frequency. In the meantime, you can communicate with the sensor, reading parameterization, monitoring, and also kind of diagnosis on board of the sensor and on board of the machinery. So this is a very important topic for me about IO-Link. We have all products with dual channel option. Then, of course, with IO-Link, it will be very easy substitution of failed parts without stopping the machinery for a lot of time, because you have to, of course, to set up again the sensor. You just change the sensor, the system will recognize that the sensor has been changed, and the parameters will be downloaded directly to the sensor. This will be very fast, and just substitute the part will be the time that you need to stop the machinery. Before it was totally different because you had to teach the sensor to make to work with the machinery to see if the teach was right or not. In this case, you just substitute the part, download the parameters, and you can go directly. Which is our portfolio about the sensor? Of course, we can start from very simple sensor, but very complete in optical functions like the S5N, which is our new tubular sensor, because we are a big producer of tubular sensor. We could not avoid to have also IO-Link on M18 format. And then this format is still a family with plenty of optical functions, going from the standard through output, through beam, retroreflector polarized, up to the background suppressor, mic readers, and also luminescence and laser emission products. So very complete, really very complete M18 family with IO-Link. Then this family, even this is the more simple one, so this is the entry level for the sensor for the industrial detection, is provided with double channel. So any kind of sensor in the portfolio will have this kind of feature, which is very important to have, as I told you, the nominal output, but also the capability to communicate with the sensor during the machine running. And then we have S100, which is our miniature entry level with very good BGS functionality and other kind of optical interesting things on this double fixing sensor, because you can double fit, you have both the fixing standard of the miniature with threaded holes on the front, which is the Asia style, and also slotted holes in the back, which is the European one. So you can substitute this sensor very easily in any kind of machinery with IO-Link, and with this kind of very fast processing of the parameterization that doesn't need any kind of human setting and spending time to get the machinery not running. In this format, we have B10, which is the B long range, background suppressor long range up to 100 millimeters, and very effective transparent sensor with IO-Link 2.3 milliseconds cycle time, and also pretty high speed retroreflex with 125 millimeters reading of the black 6% target. One thing that we have added to this family is the mark reader. So mark reader, the S100 has a very effective mark reader up to 20 kilohertz, communicating COM2, and with RGB emission and a very high sensitivity with any kind of contrast. Then we have our compact family, which is the S8, even with IO-Link. We have refurbished this family with IO-Link communication, keeping the most important and most specialized optical function with high resolution in performance, and with IO-Link protocol, which today has also a B53, which is the coaxial retroreflector polarized laser emission in class 1, up to 10 kilohertz of switching frequency. And all of them, of course, are provided with teaching but push button that works in a very simple way. For the S8, we have also included some kind of interesting smart functions. So you can make also very interesting smart task with IO-Link, like reading lifetime of the sensor, temperature, working time, short circuit, or other kind of parameter about good detection features and so on, in order to make also a pretty high level of maintenance and diagnostic on your machinery. Of course, we have also the fiber optic amplifier with double digits with IO-Link, with a very wide parameterization. Then what is very important, in my opinion, especially in terms of conveyor application. I will suggest you really that this is a very important sensor when you have to work and to detect any kind of boxes in the conveyor, and also to make those kind of postal machinery application. The S65 distance sensor background suppressor is a very good product because it can detect up to 5 meters the white and up to 3.5 meters the black 6% objects in a 50 by 50 package, which is very compact. You have double output settings, so you can set with windowing if you need to have also a kind of compressed range in measurement to be more precise. And today you have the availability of this product with analog output for 220 and 0 to 10 volts, and also with a very interesting parameters setting through the IO-Link. The application for this sensor in the packaging and cartoons line are very, very important. We have a lot of application running, especially in the wrapping machinery. When you have to wrap those kind of parts on big pallets, you can use this sensor because it's also very effective on kind of shiny tapes and so on. Then one thing that is very important for Datalogic is the contrast sensor or mark readers. The TR46 family today has been always at the top of level in the market. Today we have reached also a tremendous high frequency up to 70 kilohertz and 3 microseconds of jitter. So we have a sub-millimetric precision to detect the marks on your objects, on your packaging. And this means that you can have sub-millimetric precision in cutting and sealing your packages on the flow pack lines. Today, this sensor is provided with a very interesting parameterization. And one thing that is very important is that the TR46 with IO-Link is given into family, the basic, with a very simple setting on the sensor, and with the high-level programming product, which is also the fastest one, with display, push buttons, 3 push buttons, a big menu, very easy to go through, and a lot of receipt on board that you can assess, you can set up, and you can get when you change your production in a very easy way through the IO-Link. What is very important is that the family is with 2 modes. One that is very simple but very effective and with good sensitivity, and the second one which has a very high level of integration, even a very high level of let's say diagnosis and monitoring, because on the sensor we have put accelerometers and also position detectors, so you can install your sensor, see how your sensor has been installed on the machinery, and see also how much how many vibrations the sensor is detecting during the machinery running. This is very important for the maintenance and monitoring of your machinery, and it's also very important to understand what is going on to the machinery, and also to start some kind of prevention about the maintenance of your machinery in the region, in the area where the sensor was installed. On the TR46, of course, we have also, but this is also smart task function, which is in S8 and so on. We have embedded a very complete counter, so you can have a very good, very interesting smart counter on the product. And then we have also embedded this kind of parameterization for the vibration monitoring. So you can make a snapshot during the running of the machinery about position of the sensor and vibration, And once those kind of thresholds are overpassed because the machinery is going to be working in a different way, this will be sent through the IO-Link to the system in order to give the customer the communication that something has changed, and you can get and occur some kind of warning in the machinery. Then the things that one sensor which is very important for our line, of course, in all the applications today, you will find the request for S3N, which is our new miniaturized family with a very expert IO-Link on board and with all kind of optical functions. We will have a very good, very nice user interface, starting from the simple, very simple trimmer version, which is a general use sensor, up to the teach button version with IO-Link on board. This is a very rugged product with metal inserts and also metal connectors, so that's also for very harsh environments. And then we will have a lot of very interesting optical functions with very good distance detection and very good background suppressors, and also with very expert IO-Link parameterization and tasks. This is a very improved miniature sensor, and we have a very good optical functionality. Then the IO-Link on board S3N is the state-of-the-art of IO-Link that we have in our product, including all the smart tasks that we have developed during the IO-Link developing in our portfolio. Then, last but not least, is let's say our connection box for the IO-Link products, which can be available for Profinet and Ethernet IP field buses, and it has on board in both field bus style OPC UA connectivity. That means that you can really have a very good system which can communicate with field buses through the IO-Link of the sensor, but it doesn't overload the PLC because you can send directly data and you can retrieve data from your human machine interface using the OPC UA connectivity. This product has on board, and this is very unique on the market to have all this kind of feature. So we have a web server user interface to set up the sensor. Look, today application on the machinery needs to understand who is failing in the field buses connectivity. This kind of connection box has also the capability to have a monitoring and also a troubleshooter functionality to see where is the problem in the communication in the machinery. So you can really understand at a glance where is the problem if something occurs in the system. And then you can have the capability with this kind of web server, which is on board the sensor, so you don't need to download any kind of application on your PC. You can also set up any kind of sensor which is attached on the 8 ports of this product, on this connection box. But not only, you can also upload on this connection box the IODD files of your sensor, and the connection box can also avoid to communicate with PLC. You can even discard the PLC from your system and work with this connection box through the OPC UA and the IODD files in order to set and also to detect automatically what is attached to your box in the machinery. So it's a very, very flexible system, very easy. You don't need really to do anything which is more than upload and download files, and then you can go with your system setting without any trouble. So this is the idea, what I told to you. The connection box can communicate with the field bus, PLC, I mean Profinet or Ethernet IP. Of course, you have also Modbus embedded. And then through the OPC UA connectivity, you can go to your system, SCADA or HMI and so on, without overloading the PLC about this communication. And this is very important once you want it can be very important about safety condition because you have two separate channels, because from this channel you go through the internet, really to internet, because this is OPC UA and you can go in HMI and then also on the cloud. And with the other connectivity, you can go to your system, which has your field bus, and they can be to separate channel communication in your system. And then you have 8 IO-Link port that can be configured as IO-Link or standard IO logic port. I think that today, in order to embed any kind of system in the machinery, and since you have a smart sensor, you need also very flexible tools. Otherwise, all this kind of smart configuration and capability is lost. And you have developed a lot of things without give to the customer the good condition and the maximum capability and advantages that a smart technology can bring in the system. So, thank you. I hope I was enough clear. In any case, please don't hesitate to ask, to send also after this small webinar, to ask and send questions, to ask and send for information about products. We can also plan other kind of webinar to show, to demo some products, some working things. Once it will be possible also to travel a little bit easily, we can also try to meet each other. That's not a big matter for me. I will be very pleased. And now I leave the word to Ragawa to make the conclusion of this presentation. Thank you very much.
Thank you, Alberto. Thank you so much, and for a very detailed presentation. I think there was a lot of information. I'm sure there are also many questions, and I know it's quite late for people here in India. I saw that many people joined and they messaged saying that they could stay, but since it's long late, they had to leave. I understand. So again, once again, we're going to send a recording of this, and we're going to do, hopefully many more such sessions, educational sessions, which will share our product knowledge from leaders such as Alberto and experts such as Alberto and his colleagues. But yeah, we have 5 more minutes and we can take a few questions. If anybody has any questions, you would like to unmute yourself, introduce yourself and talk, please feel free. Raise your hand. I can unmute you and you can talk about any questions or doubts that you may have. Otherwise, please type it out in the chat window. So we'll give it a few minutes and wait. I'm sure there's quite a bit of information, and people are okay. So may not have. Now I have a few questions, maybe one question before we wrap up, Alberto, which may. Yeah. So there is now the sensor. So it's just to sort of give a brief overview that like the smart BS sensor. We call it a sensor, and very briefly, what it's for somebody who's not used it, it's sort of an entry level camera system. So it's a little bit more sophisticated than a sensor, but not as expensive or powerful as a smart camera. So can you explain a little bit about the difference between a sensor, a smart sensor, and maybe a smart camera?
Yes, of course. Let's say smart camera. I would start from the smart camera, which is the biggest, the most extensive system. Smart camera, of course, is a kind of device that needs also, I would say that the intervention of the human resources to make programming, to understand about vision algorithm and vision tools. And when you have to solve a kind of complex application on the field, especially if you have to measure or if you have to count or make some kind of precise detection, of course, this is the best solution for a smart camera because you can really program in terms of ROI and also other locators and other kind of system, this kind of application in the best way as possible. So smart camera is a system which is, of course, supplied also with a development studio, development environment in order to give the customer the possibility to set up very deeply the object. Then, what is a sensor? Photoelectric sensor, which could be called a smart sensor like a TR46, for instance, no? You know, TR46 is an application sensor that is a contrast sensor, and it reads exactly the contrast which is between, that there is between a mark, which is your referring part, and the background, which is the part where the mark is lying on the tape or on the film that you are going to analyze. And in this case, you have a sensor which is very expert to make this kind of application. And this is an application sensor, of course, and it can have some kind of smart on board today because we have microprocessors, so we can make, of course, the elaboration of what we want to detect, but we can also parameterize very well what we want to make, adapting this sensor to different conditions, you know. And maybe we have the capability today to speak, to talk, to communicate with the sensor in order to make settings or to retrieve data from the application. Then comes the Smart VS. Smart VS is something that can detect the presence or can detect the correct side of orientation of an object. That can be done with sensors, but also with a smart camera, but in a very simple way. So what is the simple way? The simple way is that you don't need, as it should be a smart camera, of complex programming in order to get the application done. You need a push button, then you need a procedure, which is very simple, presenting to the sensor the good and not good pull condition. And you can do it very easily, pushing the button on board. And then with the technology that is near to the smart camera, because we have effectively a vision sensor inside that can grab the image that has to be elaborated by the sensor. We can grab the image and elaborate the image with an algorithm that can solve that kind of application, which is the same principle of the application sensor, because we are solving the application that is a presence of a label or a presence of a cap, you know. So you are vertical on these applications using a very simple system, which is almost like a sensor, but with the technology that could be part of a smart camera. And we are just in the middle. In this kind of big region that is between the smart camera and the application sensor, we have the Smart VS. So if a kind of operator wants to make the cap present, doesn't need to call a vision programmer or a vision guy that knows the vision algorithm to make the cap presence on this bottle. Just put the bottle in front of the sensor, push the button as it should be an application sensor, and it works. So this is the main difference, but also the main advantage that you can have with a smart VS against smart camera and application sensor. So you can make application in a more extended way than an application sensor, but in a very simple way. And you can make part of the application with the smart camera. Maybe they are too over-engineered for this application, with an advantage of cost in terms, of course, of platform, because it costs less, but also of the total cost of ownership, because you don't need a big expertise in that case. Look, we really had this kind of we started this with this kind of philosophy, but it was really coming from a requirement from the field when we presented the product, because we presented also the graphic user interface, which is the web server inside, but they told us we don't want to see any kind of graphic user interface, just the push button, no other kind of things. Okay, so but you have also this kind of options. So I know that the customers, when they see the graphic user interface, they are very happy, because maybe that during the setting of the machinery, when they have to build it, they use the graphic user interface. Then in the second time, when the machinery is on the end user side, they don't have anymore the graphic user interface. They just explain how to set the sensor in a very simple way. And then user can go alone setting the sensor without having any kind of need to call expert to make software tools or software programming of the sensor. But of course, if you have to measure, if you have to make some kind of quality check, which are very complex, this is not the right product. No way. You have to use a smart camera, you have to use the vision algorithm, vision tools, and go on with this kind of things. But if you are in this kind of region with presence, absence of object, or let's say side orientation, this is very, very, very useful. And I think that you can solve a lot of applications. And there is a big demand in the market for this kind of applications. I can tell you, we could substitute a lot of smart camera.
Yeah, I was on mute, sorry. So, yes, thank you, Alberto. That's a very interesting. So, I think there is quite a bit of technological advancements since the time sensors have started. From the time we in data sensor had started 35 years ago, and you as well, you have been in the business industry for a very long time. And it's very exciting to see how sensors have really evolved, how smart they've gotten, and how advanced, both from a communication, the types of options, the specialization, and the variety that one has. And I think it's only getting more advanced, many more options. So I am sure that this was just a small teaser, a preview, a trailer to the actual range and portfolio. And I hope that most of you who are still with us, many of you, I know it's late, so we're going to conclude, have taken something out of value, and we would love to continue the conversation. Please send us an email. We have the contact details. You will see an email for all the registrations with the recording of this webinar. Please go back and watch it again. It will be on YouTube and our website. And we are always available for more questions, and happy to help solve any of